my name is Abigail Coy, and this is my senior project, a dueling robot, also known as a combat robot. I picked this project initially because I did the EET subseries, the robotics subseries for my EET program, and I found a lot of joy and fascination in working with robots and decided that I wanted to become a roboticist, and what better way to make myself hireable to employers than to build a robot. So this project had engineering merit in the way of statics, dynamics, mechanical design, and material, or mechanics of material. These can be seen throughout the 13 analysis. I did the mechanics of material are primarily in deciding the material for the end of the claw, since this is a crusher robot, the chassis material and the armor material. Statics can be seen in the earlier analysis to determine dimensions, as well as thicknesses for all the components that I will need to build the robot. The mechanical design components can be seen in designing the planetary gearbox system and determining a spring for the arm. And dynamics, same as statics, goes into determining all the little nuances of the designs for each part. The primary analyses consisted of mainly determining that this robot will be able to withstand the forces that it comes in contact with while in the ring. I used a generous calculation to determine what the max force of any type of robot would be able to exert on this robot in the ring at this weight class specifically, because as robots get heavier, they can exert more force. But in order to be able to compete at come spring quarter, there was a schedule that was determined via a Gantt chart in MS Project. It was laid out quarterly for the academic school year, with the fall quarter being primarily the design phase, focusing on analyses and working in SolidWorks to design all of the parts that will need to be manufactured and put together during the construction phase, which is winter quarter. Winter quarter will also consist of some testing along with the construction. There will be acceptance testing of the components as well as sensors, because this is a dual major senior project. There are going to be some sensors put into the robot to make it applicable to the EET requirements that are not necessary for the robot's function, but they help in handling the robot and in making all of its components work together and function properly, as well as ensuring that motors don't get over-torqued or burn out while in use. The budget of the robot was determined to be around $1,500. This is subject to change as outsourcing machining was assumed for one of the components, because I hadn't done the analysis for it yet, so I was unsure as to how I was going to build the part myself. Having now done that analysis, I can safely say that outsourcing machining will not be necessary, so this budget will go down slightly, but overall this budget won't change all that much, just because it costs quite a bit to build one of these robots, and in ensuring that I would have necessary backup parts, the parts alone cost around $800 just for the motors, the servo, the spring, the filament to 3D print the robot, since it's chassis, and a lot of the internal components will be 3D printed to help save on weight. This project, I believe, will be successful because, one, I've done the homework, I've done the analyses, I've triple-checked all of the math and ensured that everything is consistent and it is correct. I've also started prototyping the robot at home and ensured that all the parts fit together, that they work, that the gearbox actually turns. I have ensured that, because the gearbox is going to be inset into the arm itself, that it is not wider than the arm is, and so that it all fits together with room, so that there's no like overly tensioned areas, so that the parts that need to move can actually move. And I believe that is everything. Thank you.